Alright, so this is just a quick video on looking at linear inequalities on Desmos. And we just want to look at two or three of them. So for instance, I may have a linear inequality that says something like 5x plus 4y is less than or equal to 40. And now, so when I type that in, you see all of a sudden I get all this red area, and here's the line here. Now, generally for these, it's probably nicest for you if you pan and zoom on the screen to kind of see the most possible. So I'm going to grab the screen. I'm going to put it down here because typically in a lot of these problems everything's positive, so that's all going to be up in this top right hand quadrant, quadrant 1. Now I could zoom in or zoom out a little bit and move things around to make it look a little better, but this looks pretty good for this constraint. And you see what it's doing is it's showing me all x and y pairs that satisfy this inequality. So for instance, if I go here and whoops, I double clicked there, didn't mean to, so here is x equals 2, y equals 4. Now if I check that and I say, well, what's 5 times, times is an asterisk usually, 5 times 2, okay, plus, and then 4 times 4, you see I get the number 26 right here. And that is indeed less than or equal to 40. If I try a different set of numbers here, so here is, well, let's go here at 3, so there's 3 and 6, and I try that. So 5 times 3 plus 4 times 6, and that's 39, and yep, that's less than or equal to 40. Whereas if I grab a point out here, say 7 and 4, so I'm right here at x equals 7, y equals 4, and I try that, I have 5 times 7 plus 4 times 4, and that's 51. Well, that's not less than or equal to 40. So you see the shaded area gives me all combinations of points that satisfy that inequality. So now I'm going to get rid of those. And now suppose I have another inequality that is, say, something like, I don't know, maybe 3x plus, we'll go with 4y again, is less than or equal to, and we'll make it maybe 30. Let's go with, I don't know, I hadn't really thought about what I wanted to use here. Let's try 24. Okay, I don't like 24, so we'll go up to 36. I like that better. Okay, so here's another constraint, and again, it's shaded. Now it's shaded with a different color, and as we see what we have, well, it's actually kind of hard to see what I have here because of the shading. What I suggest is you change your colors. I like orange, and I'm going to make the other one orange as well, and hit done. And so now I can see better what's going on. And I have the lighter orange where only one of these two constraints is being active or has its values satisfying it. But then I've got the darker orange that has both of these. So you see where they intersect, I can see visually here the darker orange. And if I zoom out just a little bit, you see we start up here around the 9 as far as the y-axis, come down here. We use this line. Now which line is this? Well, I can again check real easily. I think that's the 36 line. We'll turn it off, it disappears, turn it back on. Yeah, that's the 36 line. And up here with the 40, the 5x plus 4y is less than or equal to 40, that's this line, the steeper line. And so now you see if I have both of these constraints or linear inequalities, I can see very quickly all points that satisfy both. And if each of these was a limitation for me in trying to solve some sort of problem, then I would call this overlapping region, this intersection of these two shaded areas, the feasible region. So this is my feasible region. Now, as I said, typically you are also constrained that things need to be positive, because often like x and y are numbers of things. Well, you know, I don't have negative numbers of cars or negative numbers of people or anything like that. Now, see, you could put that in. So for instance, I could say x has to be greater than or equal to 0, and you see it made x, everything out here to the right of the y-axis. But because I have the y-axis, I don't tend to actually add that, because I can see right here that I want to stop there. And again, I can just kind of move everything so that I'm only looking up in here as to what's feasible. But in the project, for instance, there are capacity constraints. Now, I could add a whole nother constraint that is, you know, say something like 2x plus 3y is less than or equal to 60. And notice what happened. Everything went blue. Well, actually what that tells me is anything that works up here for either of these other two also works for this. So we don't do this in the project, but this is what we would call a redundant constraint. We don't really need it because anything that's in the blue is absolutely also in these two orange areas that we had before, and so we just wouldn't bother with it. Now, but we also have capacity constraints. So for instance, we might say that, well, x can be no bigger than 5. And so you see we've added that possibility, so we can only be here over to the left. And you know, maybe y has to be less than or equal to 8. And so we get that. And as we look at this new region, we have the axes here, but then we have these 4 sides. Now that side is very, very small. These two are bigger. But we've got this total of 6-sided region that would be our new feasible region. And again, I would go here and change these to orange just so I can see a little better. I think the orange works the best for me. You know, green or blue or something might work the best for you. But here I see this darkest region all in here, not quite as dark up in this little triangle, not as quite as dark in that triangle or that one. So the feasible region where all 4 of these linear inequalities work is in here, no taller than y equals 8. And I come out here and I stop. It's not, it's between 1 and 2 somewhere. It comes down here till x equals 2. Y is between 7 and 8. And then I come down here and finally down to the 5. And that is how I enter and interpret my linear inequalities. So that's it for this video.